What would you do if the machine you built to last 5 years was still alive 49 years later, 16 billion miles from home, doing things that should have been impossible? Because that is exactly what happened. And the people who know it best, the engineers who spend their days talking to a ghost across the void, are the ones who seem the most surprised by it. If you want to follow this story all the way to the end, hit that like button, subscribe, and share this video with someone who needs to be reminded that impossible things can survive. It takes 2 seconds, and it tells the algorithm exactly who this video is for. Here's the part that should make you stop scrolling. This is not a story about a machine that quietly aged. This is a story about a machine that kept breaking, kept dying, kept running out of power, kept losing its voice, and kept finding a way to come back. Every single time. Even when the engineers themselves had written it off. Even when the evidence said it was over. And right now, as you watch this, that machine is preparing to cross a line no human-made object has ever crossed. A line measured not in miles, but in time itself. So let me tell you the whole story. The one that's been unfolding for the past 2 years, far beyond what the headlines have been willing to say. It starts with a name you probably know. Voyager 1 launched on September 5th, 1977, strapped to a rocket aimed at the outer planets. Its job was simple. Fly past Jupiter, fly past Saturn, take pictures, send them home, and then, in the polite language of mission planners, complete its objectives. 5 years. That was the deal. Nobody told the spacecraft that. The 1970s were a different world. The moon landings were recent history. Computers filled entire rooms. And the idea of sending a single machine to visit the outer planets and then keep going was considered by many to be a fantasy. Voyager was built by people who didn't believe in limits. They packed it with a full suite of scientific instruments, a golden record, and a quiet confidence that it might outlive them all. Jupiter came and went. Saturn came and went. The pictures were extraordinary. The science was done. And the mission could have ended right there. A perfect success. A footnote in the history books. Instead, Voyager kept going. Not because anyone ordered it to, but because it still could. It swung past the giant planets, borrowed speed from their gravity like a stone skipping across a pond, and aimed itself at the edge of everything. For decades, it flew, past the orbits of the planets, into a region where the sun's light grows thin and the solar wind finally gives up. And then, in 2012, it crossed a boundary called the heliopause, the place where the influence of our sun ends and the space between the stars begins. That was the moment Voyager 1 became something else entirely. Not a planet hunter anymore. The first human-made object to leave the bubble of our solar system and enter the interstellar medium. The first messenger we ever sent into the galaxy itself. And it kept going. Today, Voyager 1 is roughly 16 billion miles from Earth. The signal it sends home, traveling at the speed of light, takes more than 23 hours to arrive. Every hour of every day, it moves further away. Every year, the distance grows by more than 300 million miles. Every year, its voice gets a little quieter, its power a little lower, its chances a little thinner. And yet, it's still talking. Now, here's what most people don't understand about this mission. Voyager 1 is not a modern machine. It was built with 1970s technology. Its computer has less memory than a single page of a modern smartphone. Its wiring was soldered by hand before most of us were born. And it operates in total darkness, in near total silence, at a temperature close to absolute zero, with no one to help it, no one to touch it, no one to fix it if something breaks. Every fix has to be commanded from Earth. Every command takes more than a day to arrive. Every response takes more than a day to come back. So when something goes wrong out there, the people at JPL don't get to react. They get to wait. They send a command into the dark, and then they sit, and for 2 full days, hoping they got it right. That is the world this story happens in. A world of 2-day conversations with a machine that is dying. And in the past 2 years, that machine has been dying in ways that would have ended any other mission. Let's start with the first crisis, because it's the one that almost nobody saw coming, and it nearly ended everything. Voyager 1 has a set of thrusters whose only job is to keep the spacecraft pointed at Earth. Think of it like this. The spacecraft is a camera, and Earth is the subject. If the camera drifts even slightly, the picture blurs. If it drifts far enough, the picture disappears entirely. The antenna has to stay aimed at home, or the signal is gone, and the mission is over. For decades, a set of primary roll thrusters handled this job. Then, in 2004, they stopped working. A problem with their internal heaters, a power issue, left them cold and silent. The engineers declared them dead. That was the rational conclusion. The evidence said so. And for 21 years, the mission relied on a backup set of thrusters instead. By early 2025, the backup set was in trouble too. Residue was building up inside their fuel lines, the kind of gunk that slowly chokes a thruster until it can't fire at all. The engineers did the math. The backups could fail as early as fall 2025. And if the backups failed, with the primaries still dead, Voyager 1 would have no way to keep its antenna pointed home. The signal would fade. The mission would be over, not in some distant future that year. So the team at JPL did something that sounds almost absurd. They went back to the archives. Old wiring diagrams from the 1970s, telemetry records from the 1980s, engineering notes written before most of the team was born. They were looking for a reason the primary thrusters had failed, a reason that wasn't actually death. And one engineer had an idea. What if the heaters had never really failed? What if a glitch in the power distribution circuitry had simply flipped an internal switch to the wrong position, cutting electricity to the heaters without actually damaging them? If that was true, a carefully crafted command sequence could flip the switch back, restore the power, wake the thrusters up, bring a dead system back to life from 16 billion miles away. It was a beautiful theory. It was also terrifying. Here's why. The thrusters had been cold for 21 years. Voyager 1 has a star tracker that keeps it oriented in space. If that tracker drifts slightly out of alignment, the onboard software is designed to automatically fire the roll thrusters to correct the attitude. That's a safety feature. It's supposed to save the spacecraft. But if the thrusters fired before their heaters had warmed the fuel lines, if they fired cold, the result could be a small explosion inside the spacecraft. A burst of fuel with nowhere to go. A single catastrophic failure 49 years into the mission, caused by trying to save it. There was no way to prevent that automatic firing if the timing was off. The fix had to be executed perfectly. The heaters had to come back online fast enough that by the time any automatic correction was triggered, the fuel lines would already be warm enough to handle it safely. And there was a clock. A hard, unforgiving clock. The giant radio dish in Canberra, Australia, the only antenna on Earth powerful enough to command Voyager at this distance, was scheduled to go offline for a major upgrade. If the fix wasn't completed before that window closed, the team would have no way to try again for months. And by then, the backup thrusters might already be dead. So on March 19th, 2025, the commands left Earth. They crossed 16 billion miles of interstellar space at the speed of light and arrived at Voyager 1 more than 23 hours later. Then the team waited another 23 hours for the response to come back. Nearly 2 full days of holding their breath. And then the data arrived. The temperature of the primary roll thruster heaters was rising. Within 20 minutes of the commands executing, the numbers confirmed it. The thrusters that had been declared dead in 2004, 21 years dead, were alive again. The propulsion lead on the mission said something that everyone who heard it has remembered. He said the thrusters were considered dead, and that was a legitimate conclusion. Then he paused and added that this was yet another miracle, save for Voyager. Think about that word. Miracle. A word engineers almost never use. A word that means we did everything right, and it still shouldn't have worked. But it did. If this story has you gripping your seat a little, you're not alone. The people who live this mission every day feel it too. And if you want to be part of the small group that follows this mission all the way to its final signal, subscribe now. It's free, it's one tap, and it means you'll be right here with me when the next chapter of this story unfolds. That was the first surprise, but the year was far from over. And the next surprise was the kind that makes you wonder how much longer this can possibly go on. In early 2026, the power situation took a sharp turn. Voyager 1's power levels dropped in a way the engineers hadn't planned for. Not to zero, not catastrophically, but enough to make the people watching the telemetry go quiet. And it mattered because Voyager 1 is running on borrowed time in the most literal sense. Its power comes from radioisotope thermoelectric generators, devices that convert the heat of decaying plutonium into electricity, and that plutonium is decaying. It has been decaying since the day the spacecraft launched. Every year, the power output drops. Every year, there is a little less to go around. By 2026, the generators are producing roughly half of what they produced at launch, about 220 watts. To put that in perspective, a dim light bulb, that's the entire power budget for a spacecraft that has to keep its instruments warm, keep its computers running, its antenna aimed, and its voice loud enough to be heard across 16 billion miles. And when power drops, the spacecraft has a safety mechanism, an undervoltage protection system that will automatically shut down non-essential systems to protect the critical ones. The engineers realized that if the power kept falling, that protection system could trigger on its own, shutting down systems in an order nobody chose, possibly killing science instruments that could have been saved. So they made a painful decision. On April 17th, 2026, NASA sent a command to deactivate the low-energy charged particle experiment on Voyager 1, an instrument that measures the structure and composition of particles in interstellar space. It was one of the most valuable instruments on the spacecraft. Turning it off was not anyone's preference. The mission manager said so directly, but the power had to come from somewhere, and the LECP was sacrificed to keep the most critical systems running. After that shutdown, Voyager 1 was left with just 2 operating science instruments. 2. Out of the full suite, it launched with a magnetometer, measuring magnetic fields, and a plasma wave subsystem, listening to the vibrations of interstellar plasma. 2 instruments on a spacecraft that once carried a complete laboratory. And here's the part that makes this story not just sad, but extraordinary. Even as the instruments were being shut down, the data coming back from those 2 remaining instruments was still scientifically priceless, still revealing things about interstellar space that no other measurement in history has ever captured. There's a phenomenon scientists call the plasma hum, a persistent low-frequency signal, the vibration of ionized gas in the space between the stars. Voyager 1 detected it in 2021, and it has been measuring it ever since. It's the only real-time measurement of its kind anywhere in the universe. The magnetic field readings, meanwhile, continue to map the structure of the ancient interstellar environment the spacecraft is moving through. Every week, Voyager drifts deeper into territory that has never been directly sampled by any instrument ever built, and it is still reporting back. Then, in August 2026, the engineers at JPL attempted something they had been planning for over a year. They called it the Big Bang, not the cosmological event, their own internal nickname for a power management procedure so delicate, so precisely coordinated that it required shutting down multiple systems and switching in lower power alternatives, all at the same time in a single synchronized operation with no going back. Here's why it had to be done all at once. The Voyager spacecraft run on heat. The radioisotope generators don't just power the instruments, they keep critical components warm enough to function. In interstellar space, if a component cools below its minimum operating temperature, it fails, permanently, irreversibly. So you can't switch things off one at a time, because each switch creates a window where critical components might cool dangerously. You have to do it all at once, perfectly, in the dark, 16 billion miles away. The Big Bang was first tested on Voyager 2, Voyager 1's twin, traveling in a different direction through interstellar space, about 13 billion miles from Earth. On August 4th, 2026, the team executed the maneuver. They switched off a set of powered devices and substituted lower power alternatives that do the same jobs while using less electricity. The announcement came. The Big Bang on Voyager 2 had worked. Without that maneuver, Voyager 2 would have been forced to shut down another science instrument before the end of 2026, leaving it with only 2. Instead, all 3 of its remaining instruments will keep running for at least another year, and the mission team immediately announced that the same procedure would be attempted on Voyager 1 in the coming months. If it works, there's even a chance they can restart the low-energy charged particle experiment that was shut down in April, bringing Voyager 1 back to 3 functioning instruments instead of 2. Now, let me pause here, because there's something about this story that doesn't get enough attention, something bigger than the hardware. There is no replacement for what these 2 spacecraft are doing. There is no other mission currently funded, launched, or on a defined development path that can replicate what Voyager 1 and Voyager 2 are doing right now. They are the only in-situ sensor network humanity has ever placed in interstellar space. Every instrument lost from either spacecraft is a measurement that stops forever, a window into the interstellar medium that closes permanently, a type of data that will not be available again for decades, possibly longer. To understand why this matters, you have to understand the bubble we live in. The sun doesn't just give us light and warmth. It blows a wind, a stream of charged particles that pushes outward in every direction, carving a bubble in the space around us. That bubble is the heliosphere. Everything inside it, every planet, every asteroid, every comet, lives inside the sun's influence, and beyond its edge, at the heliopause, the wind finally stops, and the space between the stars begins. That space is not empty. It's filled with plasma, with magnetic fields, with dust, with the debris of ancient stars. And until Voyager 1 crossed that boundary in 2012, no instrument from Earth had ever touched it. The interstellar medium is one of the least understood environments in all of astrophysics. We can observe it from a distance, using telescopes, watching how light from distant stars is absorbed and scattered as it passes through. We can infer its density, its temperature, its magnetic field structure. But there's an enormous gap between remote observation and direct measurement, between seeing something from far away and actually being inside it, measuring it in real time, feeling the plasma waves and the magnetic fields directly with instruments placed right in the middle of it. Voyager 1 is the only thing we have ever placed directly inside the interstellar medium, and the data it sends back isn't just confirming what we thought we knew. In some cases, it's contradicting it. When Voyager 1 crossed the heliopause in 2012, scientists were surprised to find that the magnetic field direction didn't match expectations. The density of the plasma was different from expectations. The transition was messier, more complex than the clean boundary the models had suggested, and the magnetic anomaly that began around 2020, elevated field readings that persisted for years, is still not fully explained. Every piece of data that comes back from Voyager 1's remaining instruments is ground truth for theories built on indirect observation. The magnetometer is still measuring how the magnetic field changes as the spacecraft moves deeper into interstellar space. The plasma wave subsystem is still listening to the hum of interstellar plasma. These are not routine measurements. They are the only measurements of their kind anywhere in the known universe. If you're still with me here, then you're exactly the kind of person who should be following this channel. So hit subscribe and share this video with someone who loves space, or someone who needs a reminder that nothing is ever truly finished. And that's why the people at JPL keep doing this, why they're willing to attempt a procedure nicknamed the Big Bang on a 49-year-old spacecraft. Because the alternative is watching irreplaceable science die. The people who work on Voyager are racing time itself, not in a dramatic Hollywood way. In the quiet, methodical, deeply skilled way that real engineers and scientists work against limits that cannot be moved. They cannot make the power last forever. They cannot make the signal stronger than physics allows. They cannot make the spacecraft younger. All they can do is be smart about what remains, and they have been extraordinarily smart about it. Dead thrusters revived after 21 years, a corrupted memory chip repaired from 16 billion miles away by scattering code across memory. Instruments sacrificed in the right order to keep the most valuable ones running. Power procedures executed simultaneously on aging systems. Voyager 1 keeps surviving because the people who work on it refuse to give up on it, and that refusal is backed by genuine expertise. Decades of accumulated knowledge about a specific spacecraft. And now, the milestone, the one that no human-made object has ever reached before. On November 18th, 2026, at 2:16 in the morning, Voyager 1 will be exactly one light day from Earth. The first human-made object in history to reach that distance, one light day. Approximately 16 billion miles. When a signal leaves Voyager 1 at that moment, it will take exactly one full day to reach us. And when we send a response, another full day passes before it arrives. If you ask Voyager 1 a question on Monday morning, you get the answer on Wednesday morning. The engineers who manage this mission are essentially performing surgery on a patient they can only reach by letter, on a patient flying away from them at tens of thousands of miles per hour, getting harder to reach with every passing hour. And they are succeeding. They are keeping it alive. They are reviving dead thrusters and shutting down instruments to save power. They are somehow still coaxing science out of a machine that was built when Star Wars was still playing in theaters. Let me tell you what this story is really about. It's not about a spacecraft winding down. It's about a mission that refuses to accept that it's over. Engineers who refuse to give up. Scientists who will squeeze every last watt of power into useful data. A spacecraft that keeps defying what should be its limits. When that last signal finally comes, when the power finally drops below the minimum threshold, Voyager 1 will not stop. It will keep flying. Through the interstellar medium, through whatever lies beyond it, into the galaxy, carrying its golden record. A message from humanity, a collection of sounds, images, and greetings from a world that will be unrecognizable. In about 40,000 years, it will pass near a star called Gliese 445. By then, the civilization that built it will be almost unrecognizable. The languages we speak will have changed beyond recovery. Everything we built will be dust, but Voyager 1 will still be out there, still going. The farthest thing humanity ever made, a message in a bottle drifting through the widest ocean that has ever existed. And right now, today, it is still talking to us, still measuring, still surprising us, still finding ways to stay alive when every logical expectation says it should have stopped long ago. NASA was not expecting the thrusters to come back. They were not expecting the power drop in February. They were not expecting to still be pulling science out of this spacecraft in 2026, nearly half a century after it left the ground. But here's the thing. Voyager 1 just sent back something NASA wasn't ready for. It sent back the message that it is still alive, still functioning, still finding ways to keep going, into territory that no other human artifact has ever explored. That is not what anyone planned in 1977. It is not what the mission was designed to deliver. It's just what happened when a spacecraft built to last 5 years turned out to be built better than anyone knew, and was maintained by people who refused to accept that it was finished. On November 18th, 2026, a signal will leave a spacecraft traveling through the darkness between the stars. It will spend exactly 24 hours crossing the void before it reaches Earth. Voyager 1 will be one light day away. The farthest human-made object in history. Still transmitting, still surprising us. Still, after 49 years, finding things NASA was not expecting. That's what Voyager 1 does. That's what it has always done. And for as long as there is a signal coming back, that's what it will keep doing. One last thing before you go. In just a few months, Voyager 1 crosses that line. The first human-made object to ever sit a full light day away from home. I'll be right here covering it when it happens. So if you want to be there for that day with me, subscribe and turn on notifications. Some moments only happen once in the history of our species. This is one of them. So the next time you look up at the night sky, remember this. Somewhere out there, beyond the planets, beyond the edge of the sun's influence, there's a machine we built. Still running, still talking, still carrying a piece of us into the dark. And it's not done yet. Neither should we be.